Hey guys, welcome to the video. Hope you enjoy. Please subscribe and we'll catch you later.
This problem looks kind of different in that what we have on the inside has these arcs next to it. These represent angles. I'm going to change the names of them right now. This arc cosine x I'm going to call theta, and the arc sine of x I'm going to call beta. So it's the cosine of theta minus beta, and using the cosine difference formula, it's the cosine of theta times cosine of beta. Minus means plus, so sine of theta times sine of beta. So that's just expanding it out, putting the angles theta and beta in there. That's what it would look like. The good news in this problem is the first part says arc cosine of x. So theta has a cosine of x, or the cosine of theta is equal to x. Where it says cosine of theta, I can plug an x in for that. It says arc beta is arc sine of x, which means that the sine of beta is equal to x. That's by definition, that's what those mean. Looking at this first part a little bit more, there is this angle theta, which was what I called it, and this angle theta has a cosine of x. So from this angle, the cosine is x. The adjacent over hypotenuse is x over 1. I need to figure out the length of this other side because eventually we're asked for the sine of theta over here. It's a right triangle. We have two of the sides. I'll just put in this temporary variable of y, and I know that the Pythagorean theorem would work. X squared plus y squared would be equal to 1 squared. So y squared equals 1 minus x squared. Y, the length of that side is the square root of 1 minus x squared. That is the length of this side. So now over here in this expanded formula, when it says, what is the sine of theta? I'll go back at this angle theta and say the sine is the opposite over that hypotenuse. So it's the square root of 1 minus x squared. Now to this angle beta. Angle beta is an angle that has a sine equal to x. I'll go ahead and draw this one over here. I have no idea what quadrant or anything. I'll call this angle beta down here. And again, the angle has a sine of x. In other words, SOHCAHTOA, its opposite over hypotenuse is x over 1. That's not exactly the same triangle that we had over there, but to find this unknown side, we go through the same process. Y squared plus x squared equals 1 squared with the Pythagorean theorem. Start solving it. This length would also come out to the square root of 1 minus x squared. The only unknown we have in this expanded formula is the cosine of beta. The cosine of beta, again, SOHCAHTOA, is adjacent over hypotenuse. Adjacent over hypotenuse is this. So from the original, we extended it out. We wrote in the values. Now, this is x square root of 1 minus x squared plus x square root of 1 minus x squared. They're the same thing. So our solution is 2 of those x square root of 1 minus x squared. Problem number 14 out of our book asks for the tangent, sine, and cosine of 165. We'll just look at the tangent of 165. Using those numbers and the tangent sum formula, we can expand it out like this. It's just plugging it into the formula. And now we need to come up with the values. 135 degrees is in the second quadrant. Its reference angle is 45 degrees. The tangent of 45 is 1. But since we're in the second quadrant, this tangent is going to be negative 1. So anywhere there is a tangent of 135, I'm going to put in a negative 1. And then 30 degrees is in the first quadrant. The tangent of 30 is the sine of 30 divided by the cosine of 30, which comes out to 1 over root 3. And then we'd want to rationalize that into root 3 over 3. We'll fill that in. Both places we see the tangent of 30. And then it was 1 minus that. In the numerator, we have root 3 over 3 minus 1. The denominator, we have 1 plus root 3 over 3. And we don't want to keep a square root in the denominator. The thing with the denominator, though, is that it is a conjugate. There are 2 terms. It's not just a monomial. So if we only multiply by root 3, it would make this second term no longer have a radical, but then we'd have a radical in the first one. So instead, we're going to multiply it by its conjugate, which would be 1 minus root 3 over 3. That'll get it out of the denominator. When we multiply this, 1 times 1 is 1. 1 times negative root 3 over 3 is negative root 3 over 3. Root 3 over 3 times 1 is positive root 3 over 3. And then at the end, take the root 3 over 3 times negative root 3 over 3, that's minus 3 over 9. Those cancel out. 1 minus 3/9. It'd be like 1 minus 1/3, which would be 2/3. Up in the numerator, these two terms are not conjugates of each other. When we multiply them out, we might very well have a radical in them. So multiplying out that numerator, root 3 over 3 times 1 is root 3 over 3. Root 3 over 3 times negative root 3 over 3 is negative 3/9. We just did that in the denominator. Negative 1 times 1 is negative 1. Negative 1 times negative root 3 over 3 is positive root 3 over 3. There are no opposites here. In fact, the root 3 over 3 and root 3 over 3 combine to give us 2 root 3 over 3. Negative 1/3 minus 1 is negative 4/3. So this looks a little bit better than what we had before. One more step though. In both the numerator and denominator, we have fractions. So we're going to multiply the entire numerator as well as the entire denominator by 3, which gives us negative 4 plus 2 root 3 all over 2. We got rid of all those 3's. Very final step, I can see that the 1, 2, 3 terms that are left, this negative 4, the positive 2 root 3, and the 2, they can all be divided by 2 to give us negative 2 plus 1 root 3. That is an exact answer for the tangent of 165 degrees. Number 35 out of the assignment, it looks like this, and this is a formula that's been expanded out. If I go back to the notes, I see that it's one of these, either 3 or 4, because it's the sine times the cosine. I know that's one of the sine sum or difference formulas. The consistent thing about the sine is minus means minus. So I'll go back to this problem. Again, it's sine times cosine, so it's a sine sum or difference formula. The pi over 12 and the pi over 4. The plus sign for a sine sum or difference is consistent, so the plus means plus here. We want to add those together. That would be 1 pi over 12 plus 3 pi over 12. It's our common denominator. Add them together, we get 4 pi over 12. So we're talking about, instead of doing all these things individually, really you're saying, what is the sine of 4 pi over 12? Which is simplifying down to, what is the sine of pi over 3? Pi over 3 looks like this. We're looking for the sine. The sine in that value is going to be root 3 over 2, because that is the sine of pi over 3.